Okay, today we're going to do Unit 8, Lesson 3, balancing equations and incorporating that into classifying reactions. There are 5 different types of reactions, and the first type is called a synthesis reaction. Synthesis means to build or to create. This is a chemical reaction in which 2 or more substances react to produce a single product. So we would have A reacts with B to yield AB. That is a synthesis reaction. Notice that there are multiple reactants here. And there is one product. A few examples. And I'm going to incorporate balancing into this. Okay. If I said sodium were to react with chlorine gas, what would they produce? Well, sodium would have a +1 charge. And so what is the charge of chlorine? Chlorine has a -1 charge. So they balance out in a 1-to-1 ratio because it's +1 to -1. They cancel out evenly. But you'll likely notice that there's 2 chlorines here, there's 1 here. So this is where balancing will actually come in. You would be advised to put a 2 coefficient in front of sodium chloride. This is sodium chloride, by the way. And now the chlorines are balanced. There's 2 of them here and there's 2 of them here. But you have 2 sodiums here, you have 1 here. So put a 2 in front of that sodium and they're all balanced out. If that's a little confusing, do what I taught you guys in class, this little thing I did for myself in college. I call it a scoreboard. You just do a head count of all the atoms on each side that you have of the reaction. So I have 1 sodium, 2 chlorines, atoms that is, 1 sodium atom, 1 chlorine atom there. There's 2 chlorine atoms on the left, 1 on the right, so I should put a 2 coefficient in front of sodium chloride. That's going to give you 2 sodiums and 2 chlorines. I then put a 2 coefficient in front of sodium, and now it's all balanced out. This is a synthesis reaction because there's multiple reactants. There's one product. Let's do another example. Calcium oxide reacts with water to form calcium hydroxide. Now I want to go over why they are in those ratios, okay? Calcium has a +2 charge. Oxygen has a -2 charge, excuse me. They balance out evenly, so it is a 1-to-1 ratio. Hydrogen has a +1 charge. Oxygen has a -2 charge. It's going to take 2 hydrogens to balance that out. So +2 or +1 times 2 equals +2. That balances out oxygen's -2. And then calcium has a +2 charge. Hydroxide is a polyatomic ion you all were told to memorize. It has a -1 charge. So you need 2 hydroxides to equal that -2 charge, and they will balance out. And it is already balanced. You don't need any coefficients in front of any of the substances. It is a 1-to-1 ratio. Okay, the second type of equation is our reaction is called a combustion reaction. It is a synthesis reaction with oxygen gas as a reactant. So here's one example. Now, if you guys were to call this a synthesis reaction, I wouldn't mark you wrong, but because one of the reactants is oxygen, you need to also indicate that it is a combustion reaction. Now, I also want to balance this, so let's do our scoreboard. We have sulfur, we have oxygen, we have sulfur, we have oxygen. One sulfur, 1, 2, 3, 4 oxygen atoms there. One sulfur, 1, 2, 3 oxygen atoms there. Okay. Let's see. Well, we have a discrepancy with oxygen. So you can just try to put some numbers in, and if you have to erase them, that's fine. I'm going to try and put a 2 right there, and maybe it does something, maybe it doesn't. So that gives me 2 sulfurs, and that gives me 6 oxygens on that side. I think this is going to work. Because 2 times 2 is 4, plus these 2 is 6. 2 times 1 of the sulfurs is 2. Now, for the sulfur trioxide, if I put a 2 in front of this, it's going to give me 2 sulfur atoms. And then 2 times 3 is going to be 6. There we go. It's all balanced. Now, there is another little caveat to combustion reactions. If the other reactant besides oxygen has carbon in it, a product will be CO2 and water, H2O. So I'm going to come up with the equation with the combustion of methane. Okay. Oops. All right. 1 second. If you notice that this has oxygen, that's a clue that it's combustion. And the fact that methane has carbon in it is going to result in the product CO2 and water. So we have carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. One carbon, 4 hydrogens, 2 oxygens, 1 carbon, 2 hydrogens, 1, 2, 3 oxygens. Okay. Let's see if we can get this balanced. Let's try that. I think it's going to give me 4. Let's try this. That's going to give me 4. And that's going to give me 2. There we go. All balanced. So that is also a combustion reaction. Number 3, we're going to have a decomposition reaction. This would be the reverse of a synthesis reaction. We have a single reactant. Multiple products. This would be AB yields A plus B. You got one reactant. Multiple products. And as an added little factoid, some decomposition reactions require heat, light, or electricity to occur. Few examples of decomposition reactions. Ammonia nitrate reacts to form dinitrogen monoxide gas and water. And that is already balanced. I'm just kind of jumping ahead to it. Another example would be sodium nitride. Actually should be Na3N. Reacts to form sodium and nitrogen gas. Actually, it should be 6. There we go. Those are all decomposition reactions. Okay, and the last one for this lesson. There's 5 total. I'm getting to 4 of them today. This is going to be, a single replacement reaction. These reactions occur when a reactant, not a reaction. This is a reaction in which the atoms of one element replace the atoms of another element. So we could have A reacts with BX to form AX in B, or you could have AX reacts with B to form BX in A. Now, something that you must keep in mind here is that you cannot have a cation and a cation together. In other words, a metal and a metal, you can't have that. So you have to be sure that metal and non-metal go together whenever you have these compounds here and here. The metal is going to be positively charged. The non-metal is going to be negatively charged. You cannot have non-metal to non-metal. You can't have metal to metal. It's not going to work. So an example that I have is going to be solid copper reacts with silver nitrate, aqueous silver nitrate. That means it's dissolved in water to form silver. Oops, excuse me. I didn't mean to say that part. I wanted to see if you guys can do this on your own. So this is A, this is B, this is X. A is all by itself. B is with X, okay? Now, I want you to understand why silver to nitrate is a 1-to-1 ratio. This is something you all should have memorized, okay? Nitrate has a -1 charge. How many nitrates are there in that compound? There's 1. And so if that one nitrate all by itself has a -1 charge, what must the charge of the silver be in order to balance that out? That must be a +1 charge. That's why they're at a 1-to-1 ratio. Copper, when it's by itself, has no charge. But they're now going to flip-flop. Silver and copper are going to switch places. And so copper is going to go with nitrate, and silver will be all by itself. Now, because silver is all by itself, its charge is going to be 0. Nitrate has a -1 charge. What must copper's charge be? Well, if you look at the periodic table, you'll know that copper has a +2 charge. Does +2 balance out with -1? It doesn't. So you need multiple nitrates. You need 2 of them. So -1 times 2 will equal -2. And now we're all balanced as far as the individual compounds are concerned. But now I need you to balance out the reaction as a whole. So we have copper, we have silver, we have nitrogen, we have oxygen. We have copper, we have silver, we have nitrogen, we have oxygen. Looks like we have 1 copper, 1 silver, 1 nitrogen, 3 oxygens. 1 copper, 1 silver, 2 nitrogens, and 6 oxygens. Okay, so what do we need to do? I see a big discrepancy between nitrogen and oxygen. So I'm thinking if we put a 2 right here, 2 times 1 silver is going to be 2 silvers. 2 times 1 nitrogen is going to be 2 nitrogens. And 2 times 3 oxygens is going to be 6 oxygens. And then we need to put a 2 right here in front of that silver. It balances it out. Now, this next part is going to be really important for you guys. I want you to notice that over here, silver was by itself. And then copper was by itself, and then copper replaced nitrate. Or copper replaced silver. I'm all tongue-tied. It's the end of the day. Start that over one more time. Copper was by itself, and on the other side of the reaction, on the product side, copper replaced silver. Was that allowed? I'm going to pull down something that I have here. You are going to need to refer to this. If I can bring it down here. Come on. Okay. This is called an activity series. The way this works is starting from the very top. Any element that is above another element can replace the element that it is above. But if there's an element below another element, the element that was below it cannot replace it. So here is copper. Here is silver. Is copper above or below silver? It's above. So that means, yes, copper can replace silver. But what if I had this reaction instead? Look at this. I have silver all by itself. I have copper nitrate. Is silver able to replace copper? Well, if I look at my list, silver is below copper, so that won't work. And so you will write NR for no reaction. Okay? So there's a few examples I like to do here. Let's hash them out. Example number 1. Solid iron reacts with copper sulfate, aqueous copper sulfate. Can we do a reaction? Well, first off, I want to go over a few things before I even go any further. Iron is by itself, so it has a charge of 0. Sulfate is one of the polyatomic ions you guys had to memorize. It has a -2 charge. There's only one of them. Copper has a +2 charge. So those two balance out at a 1-to-1 ratio. So are we able to proceed with this reaction or not? Is iron able to replace copper? Well, let's take a look. Copper is here. Iron is there. Can iron replace copper? Yes, it can. It can replace it. So we may proceed with the reaction. Now, there are two different types of iron. I should have indicated that that is going to be iron 2. So it could have a positive 2 charge. So sulfate has a negative 2 charge. Iron has a positive 2 charge. That looks like it all balances out. Okay, let's go to the next one. Liquid bromine reacts with magnesium chloride. Now, you got bromine and you have chlorine. And by the way, magnesium has a positive 2 charge. Chlorine has a negative 1 charge, which is why you needed 2 of them to equal negative 2 to balance out. If you take a look at the bottom here, it's the same scheme. Any element that is above 1 below it can replace it. But can bromine replace chlorine? The answer is no, it can't, because bromine is below chlorine. So we would write NR, no reaction. That can't happen. And then finally, last one I have for you. We have solid magnesium. We have aluminum chloride, aqueous aluminum chloride. Can we perform this reaction? So you need to look up at the activity series. Is magnesium able to replace aluminum? So if it can, magnesium needs to be above aluminum. Here's magnesium, here's aluminum. And magnesium is above aluminum, so they can proceed. Now, before I go any further, chlorine has a negative 1 charge. Aluminum has a positive 3 charge. There are 3 chlorines there to balance it out, so it's going to be negative 3. That's why it's in a 1-to-3 ratio. Magnesium is all by itself, so it's going to be 0. So magnesium is going to bond with chlorine. Magnesium has a positive 2 charge. Chlorine has a negative 1 charge, so you're going to need Cl2 to balance it out so that you can have positive 2 and you can have negative 2. Okay? And that means that aluminum is going to be all by itself. But now let's get to balancing. Let's see what we got. Magnesium, we have aluminum, we have chlorine, we have magnesium, we have aluminum, we have chlorine, 1 magnesium, 1 aluminum, 1, 2, 3 chlorines, 1 magnesium, 1 aluminum, 1, 2 chlorines. Whenever you have a difference of 3 to 2, you need to get them both to equal 6. That's always the case. So we need to put a 2 here and a 3 here. So 2 times 1 is going to be 2. 2 times 3 is going to be 6. 3 times 1 is going to be 3. 3 times 2 is going to be 6. And put a 3 in front of this magnesium. 3 times 1 is going to be 3. And put a 2 right here. Whoops. 2 times 1 is going to be 2. So now it's all balanced out. So these are single replacement reactions. Hope that's helpful. Next lesson, we'll go over double replacements.